All right, here we go. Home workout, guys. Friday, weekend. So we had 2 through 20. Oh boy, I gave you a lot of homework. Hopefully you tried that new technique for comparing fractions rather than getting common denominators. It's pretty slick. All right, here we go. I'm gonna call them out. Once again, I don't know why I started with 2. It's probably because I was lazy and I meant to say evens, or I just copied evens from the previous one. There was nothing wrong with question number 1. All right, number 2 is greater than. Number 3 is less than. I wish I could show you some symbols here. Number 4 is less than. Number 5 is equal. Number 6 is less than. Number 7 is greater than. And number 8 is greater than. All right, least to greatest, least to greatest. These were painful, right? 3/8, 5/9, 4/7. Number 10, 2/9, 3/5, 5/7. Number 11, -5, 5.6, and 107/18. Number 12, -35/8, -3.8, -3. Number 13, 4/15, 7/24, 5/16, 1/2. 14, -5/6, -7/9, -3/5, -3/7. All right, the halfway point ones. Remember, you got to add the two fractions, divide by 2, or in other words, multiply by a half. Number 15, 71/126. Number 16, 61/88. Number 17, -17/100. Number 18, -7/78. Number 19, -1/2. And number 20, 1 and 11/15. Now, if you left that as a mixed number, what would that be? 26/15? Okay, that was it. Count how many you got wrong. Answer question 1 on the Google Forms. Okay, so here's the calendars Friday. We'll have a quiz on Wednesday. So we'll talk about what will be on the quiz. Well, I'll just say it's going to be 11-1, 11-2, and 11-3, obviously. Those will be what will be on the quiz. But I'll tell you more specifics on Monday. All right, here's your homework. Copy it down, please. It's also on the bottom of the Google Forms. All right. I would say 3/4 of this is just simply review from pre-algebra. Actually, with the exception of Madison and Rio, since I had all you guys last year, there's nothing new here. This is just a review from pre-algebra. But probably for Madison and Rio, the last part of this you may not have seen before. All right, so basically the whole class is on converting fractions to decimals and decimals to fractions. And no, don't use your graphing calculator that has the fraction button that does it automatically. Okay, if you haven't already realized, remember this whole chapter deals with rational numbers. If you haven't already realized, fractions are decimals and decimals are fractions. They're the same thing, they're just in different forms. 0.5 is 1/2 and vice versa. All right, so today we're going to be changing fractions to decimals. Well, remember there's 2 types of fractions. We'll handle each one separately. All right, so write this down, please. And yes, this is the same slide I showed you last year in pre-algebra. The first type of decimal number is called a terminating decimal. Terminating decimal. An example will be the fraction 12/3. Well, 12/3, when you convert that to a decimal, right? Remember, you divide the numerator by the denominator or top by bottom. You get a number, and that number stops. Like it doesn't continue on forever. So that is called a terminating decimal. And you're like, wait a minute, there's no decimal. Well, it's 4.0. I know what you guys wanted. You wanted one like this, where you divide the numerator by the denominator. 1 divided by 4 is 0.25. That's the more normal form of a terminating decimal. But I do want to remind you is that 4 is a terminating decimal as well, too. 4.0, right? Okay. So to convert a fraction, a terminating decimal that in fraction form, convert it from one to the other, fraction to decimal, simply divide top by bottom. Hopefully I don't have to teach you guys long division. Just one quick note, and I am going to show you the work of long division. And just to remind you, remember we're just polishing our techniques here. This is not a class on long division, but just reminding you, I always recommend moving the decimal to the very top before you actually do the division, right? In other words, as long as your divisor 5 is a whole number, immediately move the decimal to the top. If it's not, obviously you do the moving the decimal a few times. Okay, and that just keeps all the numbers in place. All right, so game number 1 is simply convert fractions to decimals. So go ahead and convert both of these fractions to decimals. They are both terminating. And then write your answers in for question number 2 on the Google Forms. Okay, how'd you do? Well, hopefully you, I mean, half of you probably already realized you didn't have to do any division on the first one if you realized the denominator there was 10. For those of you that didn't realize that, well, okay, you got to divide 10 into 7. You notice what I always move that decimal immediately to the top as long as the divisor 10 is a whole number. And that way I don't have to worry about it. I know it's in the right place. 10 doesn't go into 7, add a 0, right? 10 goes into 77 times. Okay, for the second one, so obviously the answer is negative 0.7. We leave that leading 0 there just as an indicator for the reader. It is not essential. It doesn't have to go there. I'll just say, over the course of many, many years, we've gotten to the habit of always putting that leading 0 there. It's just a good habit to be in, and that way you can't mistake a decimal number for a whole number. Okay, how about 5/8? Let's see, 8 doesn't go into 5, so I move the decimal to the top, add a 0, 8 goes into 50, about 6 times, remainder 2, add a 20, 2 times, remainder 4, and we finally get to the answer, which is 0.625. Cool? Did you get both of those right? I hope you did. You're in Algebra 1. How do you handle mixed numbers, right? Well, there's 2 ways of doing it. Well, the first way is, well, convert it to an improper fraction. Remember, 8 times 1 is 8, plus 7 is 15, so we get 15 over 8. And then just do that math, 8 into 15, okay? So this is, we'll call this technique number 1. Maybe not the preferred technique, but method number 1 is convert mixed numbers to improper fraction, right? And then you do the math. Now, method number 2 says this. Method number 2 says, well, wait a minute. We already know that 1 is the whole number, so the 1 is on the left of the decimal place. So all I really have to do is divide 7 by 8. I will get 0.875. So those are your 2 techniques. 1, convert it into a improper fraction and then do the division. Or 2, just realize that any number, right, to the right of the decimal place on a mixed number is the whole number, right? And I shouldn't say whole number, I should say integer, because it could be negative. Okay, so if it was negative 1, and so it would be negative 1.875. Okay, does that make sense? All right, so 2 techniques once again. Obviously, some of you realize it's 3/10, so that's kind of easy to do. But if you want to use method number 1, see 10 times 3 is 30, plus 3 is 33 over 10. Divide 10 into 33, that would go 3 times. Notice I still move the decimal to the top. Remainder 3, so 3.3. Okay. Technique number 2 is, notice that it says 3 and 3/10. So the number to the left of the decimal will be 3, because it's 3 and 3/10. And then divide 3 by 10. 10 goes into 3.3 times. There's two techniques there. Obviously, the second technique has the least amount of math. But because we're generally in the habit of, when we add, subtract, multiply, and divide, we change all mixed numbers into improper fractions. I just wanted to show you that it can be done 2 different ways. So I'll let you pick and choose. Remember, this isn't new stuff. This is just a review. So here's box number 5. Go ahead and convert this one to a decimal. You may use either technique. Oh, and I forgot to say, and then answer the next question on the Google Forms. Okay, so for me, I'm going to go with technique number 1, not because it's easier, just because I'm a creature of habit. Let's see, 15 times 2 is 30, plus 9 is 39 over 15, and it's negative, so negative 39 over 15. 15 into 39, move the decimal to the top. 15 goes into 39 twice, 30. With 9 left over, 15 goes into 96 times. You just got to be careful because you'll do this long division and then you'll forget that the original number was negative, so negative 2.6. Second technique, notice the number to the left of the decimal place, negative 2, coincides with the integer of the mixed number, negative 2. So if you divide 9 by 15, you get 0.6. Okay? So hopefully that was enough review that you knocked the rust off of converting fraction, at least fractions to terminating decimals. All right. Okay, on to the second type of decimal number, and that's called a repeating decimal. And this is when you do that long division and you get a number that keeps repeating, or a series of numbers that repeat. So for instance, I don't know, 0.6666666 or 0.16161616. Now, you can have lots of digits. It could go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Tonight for homework, mostly you'll see 1 and 2 numbers repeat. Okay, so the definition says division that infinitely repeats a number or a series of numbers. For example, you do the long division and you get 0.333333. You can write, remember, repeating decimals in 2 forms. This is called the ellipse form, or ellipses form, and those 3 dots there, or you can have the bar over the top. We'll talk about that here in a second. By the way, that is the fraction 1/3. When 3 goes into 1, you got to add a 0, so 10. 3 goes into 10 3 times with 1 remainder, and the division never stops. Okay? So remember, the number that repeats, 3 is what's being repeated, is what the bar goes over. You don't put the bar over the numbers that do not repeat. When you do 5, 6, you get 0.833333. So that's in ellipses form, and that is in the bar form. Or you put the bar over just the number that repeats. 8 doesn't repeat, but 3 does. Okay. Once again, straight up review. This is not new to you. All right, so 2/3, if you do that math, you get 0.6 repeating. There are your 2 forms. Notice I skipped the long division. But there's other numbers that may or may not be repeating decimals. You're not going to know until you actually do the division. For instance, 15 over 11. It turns out when you do 15 divided by 11, you get a repeating decimal. You get 1.363636. So the number that's repeating is 36. So either in ellipses form or in bar form. Make sense? All right. So let's do one together. 9 into 7. Let's see. 9 into 7. Well, it doesn't go. So add a 0. Move the decimal place first. 9 goes into 70. What? 7 times? 9 times 7 is 63, which gives you a remainder of a 7. And you can see it just keeps going on and on and on and on. So it's 0.7 repeating. Okay? Both forms. Let me look at the homework real quick. Does it ask either form? It just says write the number as terminating or repeating decimals. So it doesn't, I'll just say, looking at the answers in the back of the book, and they all use bar form. All use bar form. And I'm looking at all the answers, and the longest one has 3 repeating decimals. The longest one has 3 repeating decimals. So nothing with 4, 5, or 6. All right, so go ahead and do this one all by yourself. Write the answer in the Google Forms, and then come back for the answer. Let's see. 9 goes into 5, doesn't go. Bring decimal to the top, add a 0. 9 goes into 50, 5 times. 45, well, we got a remainder of 5, add a 0, and notice it just continues on and on and on and on and on. Okay, so 0.5 repeating. Cool? All right. You had this last night for homework as well, too. They're going to give you 4, or is it 4 numbers they give you? I'm looking. Actually, there's none of these, but I noticed that I did not cover this yesterday, so I'll just cover it real quick. When you order numbers from least to greatest, and generally it goes least to greatest. I've seen some math books where occasionally they ask you greatest to least, and that's a kind of crummy technique because you're expecting least to greatest. And I will just make a promise to you, I will always give you least to greatest. So if we go from least to greatest, well, geez, you got a mixture of decimals and fractions. So you got two options here. You could change them all to fractions like last class. Okay. Well, we would have to change them all to fractions, and we'd have to get common denominators. Sounds like a lot of work, and it would be. Or method number 2, convert them all to decimals. And what it is work. It's not like it's so much easier. It's still work, but you do skip that step of making common denominators. So it does save a little bit of time. So what I would always recommend if you're trying to place numbers from least to greatest and you have a mixture of decimals and fractions, just change them all to decimals. So using the techniques that I just taught you, divide the numerator by the denominator, change them all to decimals, step one. And then step number two, simply identify which one is the smallest number there. Which one is the smallest number? Negative 0.6. But remember, originally, that was negative 3/5. So they do want you to write your answer using the original numbers. So even though that negative 0.6 is the smallest number, remember that really was negative 3/5. So they want you to write least to greatest in original form. Okay. So the next smallest number would be negative 0.2. And then what? 0.25, but 0.25 originally was a quarter, and then 1.1. There we go. So sorry for not showing you that last class, but hopefully you guys figured that out. All right, here's really game number three. Game number three is just the opposite of that. So I'm going to give you decimals this time, and you're going to convert them to fractions. Go ahead and write this down. These are the 4 steps. If you already know how to do this, you don't need to write this down, obviously. But for those of you who need a little bit of assistance, write these 4 steps down. These are questions, 17 through 28 on the homework tonight. Okay, so you've written those down. Let me show you how this works. So 1.25. It says rewrite the numbers to the left of the decimal. So the numbers to the left of the decimal are 1, so it says to write 1. Remember, we're converting a decimal to a fraction. Step number 2, write the numbers to the right of the decimal as the numerator, so 25. And the denominator, remember, we look at the last digit, not the first digit of the decimals. The last digit of the decimal is a 5. The 5 is in the hundredths place, so you put 25 over 100. And then lastly, reduce the decimal, or reduce the fraction. So 25 over 100 reduces to 25 goes into 25 once, 25 goes into 100 4 times. So the steps are write the number to the left of the decimal 1, write the numbers to the right of the decimal 25, and then the denominator would be the last digits. Let's look at another one, 1.75. Write the number to the left of the decimal. Write the numbers to the right, 75. The last digit there is 5. It's in the hundredths place, so 75 over 100. Notice the instructions also say count the number of digits as the decimals, 75. So I've got 2 decimal places, so that would be adding 2 zeros or 100. Either way works. We do have to reduce the fraction. Let's see, 25 goes into both of those numbers. 25 goes into 75 3 and into 100 4 times, so 1 3/4. Make sense? You want to do another one? Okay, let's do one more. Numbers to the left would be 2. The numbers to the right would be 3. That's only 1 digit, so add 1 0 10, or 3 is in the tenths place. Reduce, well, it already is reduced, so you're done. All right, here are 3 numbers. Please write these in fraction form, and then answer the Google form question, whichever number we're on. How'd you do? Okay, so the number to the left is 1, the number to the right is 2, so that'd be 2 tenths. That would reduce to 1/5, so 1 and 1/5. Second one, well, there is no number. I guess you could put 0. 1 over 10 is good enough. Okay, and the last one, negative 12 is to the left, 16 is to the right, 16 over 100. Let's see, what goes into both those numbers? 4. 4 goes into 16 4 times, 4 goes into 125 times, so negative 12 and 4/25. Woohoo! All right. Last year, you were introduced to this process of how to turn a repeating decimal into a fraction. A repeating decimal into a fraction. So some of you may remember it, and I know some of you did very well on this. Others of you, yeah, you had your first shot at it last year. Let's get it right this time. So this is really messy. The rules are kind of simple, but it is a little messy. All right, so step number 1, we're just going to write down the steps. So here are the 4 steps to change a repeating decimal to a fraction. Like I said, Madison, Rio, I'm not sure if you guys have seen this before. I know everyone else has seen this before. So write down these 4 steps. This was absolutely 100% needs to go on your resource card. I'll put at least one question on the test. And like I said, the steps aren't very memorable. For those of you that are reading the steps, you're like, what? What in the world does that mean? Don't panic. Just write down the steps. And I will remind you, you've done this before. Okay, so let's see how this works. Put your pencils down. Watch me do one. All right, so it says step number 1, let n, capital letter N, equal the number. The number is 3.6 repeating. So I literally let n just stands for the number, n equal 3.6 repeating. There's nothing special about the letter n. Some books use lowercase, some use uppercase n. Most books do use n though, but you could use x if you wanted to. Step number 2 is the hardest one to understand. Here's what it means. Look at just the repeating decimal. How many numbers are repeating? Well, just one. 6 is repeating. If it was 3.12121212, there would be 2 numbers repeating, 1 and 2. So it says multiply step 1, that's n equals 3.6 repeating, by 10 to the number of repeating decimals. Well, there's only one repeating decimal, so that's 10 to the first. 10 to the first is the number 10. 10 squared is 100, 10 to the third power 1,000, so forth and so on. So we're going to take that first step. See there on the upper right there, n equals 3.6 repeating. We're going to multiply both sides by 10 to the first, which is just 10. So let's see, 10 times n, remember we've got to multiply both sides. 10 times n is 10n. Now 10 times 3.6 repeating, let's see. Remember that's 3.666666666. And remember multiplying by 10 or 100 or 1,000 is simply just moving the decimal place. If I multiply by 10, I'm moving the decimal place one place to the right. If you need to rewind and hear that again. Okay? So I get 36.6 repeating, because remember those sixes don't stop. Okay. Step number 3 is also a little hard to understand, but easy to do. It says, take step number 1, n equals 3.6 repeating, and subtract it from step number 2. Step number 2, the answer was, well, it's right there, 10n is equal to 36.6 repeating. So basically, I'm taking that first line, putting it underneath the second line, and subtracting. Now, here's where the magic occurs. Check this out. You're like, well, how do I subtract with repeating decimals? Well, just think about this. 0.6 repeating just means an infinite series of 6s written down. Well, they both have an infinite series of 6s written down. So when you subtract, all of those repeating decimals go away. This is the magic. 6 minus 3 is 3. So look what happens when you do that subtraction. All the repeating decimals went away. We've gotten rid of the repeating decimals. Hallelujah, right? We can solve this now, which is the last step. Divide both sides by 9, and we get to our final answer. Well, n equals 33/9. Now, you do have to reduce since it's a fraction, so we get, what, 11/3? And if you don't believe me, take your calculators right now and divide 11 by 3. You get 3.6 repeating. Now, your calculator, remember, rounds the last digit. So that's why yours says 3.6666667. Okay. Some calculators don't do that, but most calculators do. The TIs do that. Okay. For those of you that heads are spinning, right, well, then you don't remember doing this last year. But for those of you that need to practice, don't panic. Let's do one together. All right, here we go. Write this down on a piece of paper. So 2.38 repeating. Now, the 3 doesn't repeat. It's just the 8. Okay, so step number 1 is simply you take that number and you let n equal it. Remember, you can always pause the video, rewind, listen to this again. So if I talk too fast, right, make sure you make use of that pause button. All right, step number 2, how many digits are repeating? Is the 3 repeating? No. Is the 8 repeating? Yes. So it would be times 10 to the first power because only one number is repeating. If 2 numbers were repeating, it would be 10 squared. If 3 numbers were repeating, it would be 10 to the third power. Well, 10 to the first power is 10. So step number 3 says multiply both sides by 10. Okay? Remember, I got the 10 from the fact that one number was repeating. If it was 2 numbers, we'd multiply both sides by 100. If 3, we multiply both sides by 1,000. So check this out. Remember, multiplying by 10 just moves the decimal place once to the right, which is now the number is 23.8 repeating. Remember, that's 23.888888888, so forth and so on. Step number 3, take your first step and subtract it from the second step. You see what I did there? All I did was take that first thing I wrote and wrote it underneath the second one. So some people that have practiced at this, they don't do it this way because they want to save themselves. They'll write step number 2 above step number 1, and it just simply saves one step. Hopefully that made sense. It just keeps you from rewriting something. All right, let's do subtraction. You're like, well, what do I do? I'm not sure what to do. Well, remember, the first thing there, 10n is equal to 23.8 repeating. You don't put a 0 there, right? You put an 8 there because 8s are being repeated. 8s are, because that's 23.8888. We don't put a 0 there like we normally would do for subtraction because it's not a 0 anymore. It's an 8. Now look what happens when we do the subtraction. Right? 0.8 repeating minus 0.8 repeating is 0. That first 0.8, right, even though I left the bar there because it originally was there, it's just an 8. 3 minus 8 is 5, so we get 21.5. Once again, we do this process to make the repeating digits go away. This allows us to actually solve this. Divide both sides by 9, right? 10n minus 1n is 9n. So divide both sides by 9, and we get to an ugly fraction. What do we do? Well, remember, you can't have decimals in a fraction. That's not the definition of a rational number. Rational number is two numbers compared by division where they're both integers and the denominator is not 0. So we do that little trick where we simply multiply top and bottom by 10. In other words, we're just moving the decimal place once to the right for both the numerator and the denominator. So 215 over 9. I just multiplied top and bottom by 10, and that got rid of that decimal. We do need one. So what happens when you have more than one repeating decimals? All right, let's do this one. So 0.42 repeating. Jack, don't say it. All right, 0.42 repeating. Jack knows an easier way of doing. Now, that only works, Jack, for the ones that look like this. The previous one, it doesn't work. But for this one, yeah, you can use that trick. Hopefully, Jack remembers the trick from last year. All right, so here we go. Well, let's see. Step number 1 says let n equal that number. Step number 2 says you got to multiply both sides by 10 to how many digits are repeated? Well, how many digits are repeated, Sierra, this time? That's right, 2. So we're multiplying by 10 squared. Well, 10 squared is 100. So we're multiplying both sides by 100. 100 times n is 100n. And remember, when you multiply 100, you're just you're moving the decimal place 2 places to the right. So if you move that 2 places to the right, you get 42.42424242, so forth and so on. Okay? Make sense? Subtract step number 1 from step number 2. Look at that magic. The 4 2's are going to go away. So we do subtract. 100n minus 1n is 99n. And then divide both sides by 99. Reduce. Let's see, what goes into 42 and 99? I think 3. Is that it? Yeah, 3. 3 goes into 42, 14 times. So we get 14 over 33. If you doubt me, divide 14 by 33 and look at the magic on your calculator, 0.424242. Notice the last digit is a 2 because remember the next digit would be a 4, so you wouldn't round up for that particular one. Okay? Make sense? Okay. So tonight for homework, I'm trying to count here real quick. I count 1. How many did I get tonight for homework? 2 through 26. So I'm counting 1, 2, 3. So I gave you 3 repeating decimals that you have to change. Okay. All right. It might help for those of you to play the video when you're doing your homework so you can see the steps again and watch me walk through. There's also a good example in the book. It does one with 3 repeating decimals. So they're multiplying each side by 1,000. But it's the same procedure. Okay. All right, good luck with your homework. Hey, email me if you have any problems. And for the few of you that did not do well on your test, remember you can take a retake. You just have to email me, right? Some of you have some pretty low grades. Not most. Most people did fine. Shayla, unfortunately, we can't do the donut thing. Shayla got a perfect score on her test. So did a bunch of people. But we'll do that next year. I'll just probably bring in donuts next year and just forget the competition. We need to celebrate for something. So free donuts for everybody. All right. I'll see you guys on Monday.